Welcome back, everyone. I wanted to start us off strong this time, and we're going to be practicing defense evasion. Specifically, rather than focusing on a single common EDR tool or antivirus solution, we're going to focus on something that is present in every single Windows system natively. In an enterprise and home editions of Windows, everything. And that is the anti-malware scan interface. Now, to perform this, you're going to need local admin access to the host and a short demonstration of what the anti-malware scan interface is as such. Now, anytime a command interpreter, let's say PowerShell, CMD, even some DLLs are loaded onto the system, AMSI.dll is loaded into that process. And what this does is it says, hey, every time you try and run some kind of code, before you run it, send it over to me and I will give you either a 0, it's good to go, or a 1, it's bad. And it's going to say, hey, this code that you're trying to run, some bad stuff. Don't do it. Or it's going to give us the, okay, this is perfectly fine to run. However, what we're going to do to bypass this is actually fairly simple. Instead of sending code to AMSI at all, what we're going to do is we're going to spawn PowerShell, and we're going to override this pointer pointing back to AMSI after it's been loaded into our PowerShell with a null pointer. This means that it will always return true, always return to 0. And it will allow us to run any code we want. Alright, as promised, we are currently running on a Microsoft Windows 10 Enterprise Edition. This is with full Defender activation. All these settings are active. All of the domain, private, and public firewall settings are all active. And what we're going to do is we're going to purposely fail AMSI the first time, just for demonstration. And the second time, we're going to dump the credentials from the host, bypass AMSI, and not let a single file touch the disk for an artifact. So, just like I was explaining earlier, if we list everything that AMSI is currently loaded into, we see our current PowerShell actually does have AMSI loaded into it. And a simple fileless bypass of this involves using the system management automation tool and essentially throwing some base64 strings in there to reference AMSI, which if you decode this base64, that's essentially what it is, and we're setting it to a null pointer. Now, Defender should flag this as malicious and stop us in our tracks, which it didn't, right? And if we do this, by all means, this should normally be stopped by AMSI. However, because we've set this null pointer, we get full execution of Mimikatz without ever having any file touch disk, and we can reference it as long as we have an internet connection. All we're doing in this case is invoking expression, downloading a string from PowerShell Empire, specifically the invoke Mimikatz command. We are running it in file as soon as we invoke it, and we are dumping local credentials. Fairly simple. However, notice how we didn't get stopped by AMSI, and if we hadn't performed that bypass in the first place, let's say I spawn another PowerShell administrator window here, and notice what happens when we try and do it directly. There's AMSI. And you see right here, PowerShell attack tool, severe. This is what Defender would normally do as long as AMSI does not have a null pointer set on it. Now, I know what you're thinking. Dylan, this is the part of the video where you show us how to detect this in Splunk. Unfortunately, for this time, I cannot. The reason for that is because of 2 reasons. First, that you have to enable PowerShell logging through group policy, which you would need specifically module and PowerShell script block logging. And second is even if you do enable these, You have to figure out a way of how to actually forward these to your Windows Event Forwarder and put it into your seam, be that Splunk, Logarithm, Microsoft Sendle, so on and so forth. A lot of these PowerShell events, even in the time I haven't refreshed this, there's 14,000 new events for this one host. You will, if you turn this on at a domain level, at least PowerShell logging, you will get hundreds of gigabytes of data ingested into your seam per day. Most enterprises cannot afford that kind of data ingestion, nor can any SOC or any MDR service go through that much data. Not reasonably, at least. So, I really do recommend only enabling PowerShell logging on sensitive information systems, such as domain controllers, servers, and maybe even a few administrative or domain admin PCs, just in case their credentials get popped. And as you can see, a lot of this really is just noise. We can see a couple of invocation of script blocks in the event viewer. We can see some gibberish data, a little bit of timestamps, event code, everything from 4103 to 4108. And really, only every now and then do we actually get something of value, like something like this. Now, this would be interesting to us if we were trying to build a detection, but again, this is only the reference to Mimikatz. We don't even see the command that spawned this. We only see the actual PowerShell output from running the Mimikatz command. The downside of this kind of attack is because it's fileless, because it's not making any changes to the registry, because we're not modifying a process, we're not injecting code into it, we are simply taking this one PowerShell window, we're not spawning any child process off of it, we are only making a null pointer to AMSI. That is all that we're doing. This attack is extremely hard to detect, and even I have no idea how to actually detect this. I've read through multiple different documents on preparing it. PowerShell logging is honestly the best that I've been able to find, but at that point, I'll have to leave it in your hands, and I hope you learned something. If you ever run into any red team exercise on passing AMSI, or if AMSI's giving you some trouble, throw this at it. See if you can still get past that nasty AMSI and get your code executed. Until next time, have a good one.